Density. What is density and how do we calculate density? So I know we started looking at density last week, but upon thinking about it, I realized that what I was showing you was really difficult and it doesn't need to be. So at any point you can pause this. I am also putting out in Google Classroom this presentation from Google Slides. I just wanted to do a video because my voice is starting to go out and I need to save it as much as possible. So let's go ahead and get started. Density. What is density? Density is the amount of mass in a given volume. And that can actually sound a little bit confusing. So let me tell you another way of looking at it. Another way of looking at it would be how tightly packed the atoms are for the mass in the given volume. So if you were given a volume, container, its density would be how close and how tightly packed those atoms are for that mass, for that volume. So let's look at a picture. So here we have a picture. We have one object, we have another object, a third, and a fourth. Now each one of them are the same exact volume. They all have the same exact volume. But what's different is the atoms, the molecules within that volume. And if you take a look at it, this one here has very few atoms inside this volume. Well, if the lower the number of atoms within a volume, then we have less density. They're not tightly packed. They have room to move around. There's plenty of air in between the atoms. So we say that it is less density. As we go up the scale, you can see that the atoms are increasing in number until we come down here to this final object, this final volume. Now what's happening is that, as you can see, the atoms are tightly pushed together. There's very little room for them to actually move around because of the volume is the same all the way across. The density of this object within this volume happens to be more density. The more atoms packed into a volume, the more density it is. The fewer atoms within a volume for an object, the less density. So let's try a few problems. Which is more dense based on the definition? So circle the letter that shows the object with the more density. And these are actually the very same size volume. If you selected B for being more dense, you'd be absolutely correct. B has more atoms within the same given volume as the other object. So, because it has more atoms and they're more tightly packed, B is more dense. Let's do that again. Which is more dense based on the definition? If you happen to circle A, you're absolutely correct. As you can see, these two have the same exact volume, but A has more atoms within its volume. So they are more tightly packed, meaning they are more dense. One more. So, which is more dense based on the definition? If you selected A, you're absolutely correct. It is not a lot more dense than B, but it does have more atoms within the given volume, so it is more dense. Let's continue. So, here's something you need to know. The more dense, the heavier an object is, and the less it will float. Ooh, more dense, less float. So with that being said, less dense an object, the lighter it is and the more it will float. Less dense, more float. So let's take a look at a couple of drawings. Here I have a cup of water. Water has a density of 1, okay? If the object that you put into this glass of water is greater than 1, the object is going to sink. So here is my object. My object obviously is more dense than water. Because it is more dense than water, it sank to the bottom. Ready? More dense, less float. Now let's look at this one. The less dense, more float. So here I have the same exact cup of water, and if my object is less than 1, because my water has a density of 1, if its density is less than 1, it will float. Well, and that has to deal with the amount of volume. So here I have my object. My object is obviously less dense than the first one, so it's going to float more. And so it is less dense than water. So let's go ahead and try a couple of problems. Which object will float more? Object A or object B? Circle your answer. Okay, now remember, more dense, less float. Less dense, more float. So, which one of these is going to float more? The one that has the molecules that are, the atoms that are more tightly packed, or the object that has the atoms that are less tightly packed? Well, if you chose A, you're absolutely correct. Less density means that there are fewer atoms within a volume, so it will float more. Let's do that one more time. So remember, more density, less float. Less density, more float. So which one will float more? Well, if you said B, you'd be 100% correct. Good job. So, density is the ratio of mass to volume. Well, what does that look like? Well, here are our variables. D equals density, M equals mass, and V equals volume. The formula for density, it can be expressed as D equals mass to volume, because remember, it's a ratio. Can also be expressed as D equals mass divided by volume. Or, the way I like to show it, D equals M, mass, divided by volume. The formula that we're going to be using the most is actually this bottom one. All three of them are saying exactly the same thing, but for formula's sake, we're going to be using this lower one. So make sure you write those down on your notebook. And then we're going to solve some problems. Okay, let's get started. So density. The units of measure for density are: liquids are grams divided by milliliters. Remember, masses unit of measure is grams. If you are dealing with a solid, it's going to be grams divided by centimeters cubed. So if you have a solid, we're dealing with this one. If we are having a liquid, we're going to label it with this one. So remember, you can always use your calculator. So I want you to go ahead and try this problem. Be sure to show your work. A wooden block has a mass of 562 grams and a volume of 72 centimeters cubed. What is the density? Okay, let's go ahead. If you still need more time, pause this video and then start it back up unpause it when you're ready to go. So let's take a look. So the formula is, and this is the way it should probably look on your paper, D equals mass divided by volume. Then we need to go and do substitution. Substitution says that I have 562 grams divided by 72 centimeters cubed. I'm just going to go back and double check the amounts. Okay. So, presto changeo, use your trusty dusty calculator, and D, the answer is D equals 7.80 grams divided by centimeters cubed. That is technically what our density is for that problem. If you got it right, good job. Let's go ahead and continue. Here's another one. Again, make sure you use your calculator and show your work. Again, if you haven't quite finished yet, I'm going to go ahead and would like you to pause this and finish the work. And when you are done solving it, I would like you to go ahead and unpause it and continue on. So density, here we go. The formula is D equals M divided by V. We are going to substitute, so D equals 62 grams divided by 72 centimeters cubed. And our final answer is D equals 0.86 grams divided by centimeters cubed. So that's the answer. Did you get it right? I hope so. All right, let's continue on. One more. Okay. Again, if you haven't finished the problem yet, go ahead and pause this video, and when you're done solving the problem, go ahead and unpause it, and then you can check your work. So let's go ahead and move on. A bottle of water has a volume of 560 milliliters and a mass of 1,250 grams. What is the density? Our formula is D equals M divided by V. I'm just going to double check the numbers. Okay. D equals 560 milliliters divided by 1,250 cubic meters squared. And our answer is D equals 0.44. Now I put the 8 down. Technically, you would round this up, and since this 8 is greater than 5, the 4 would normally go up to a 5, but I decided not to do that yet. So the answer is 0.448 milliliters, because that's a liquid, and it's divided by centimeters cubed, centimeters cubed. How did you do? Did you get all 3 of them right? I hope so. Let's move on. So density. So the more dense an object is, the heavier it feels for the same volume. So let's think about an old joke. It's been around for, years and years and years. And the joke says, what weighs more, a pound of feathers or a pound of bricks? So what weighs more, a pound of feathers or a pound of bricks? And go ahead and write your answer on your slide. And let's go ahead and check the answer. The answer is a pound is a pound. They weigh the same. But here's what I was trying to point out. The amount of each object will be greatly different. Oh, it looks like I have a typo. Oh no. I'll try and get that changed, but I do have a typing error, and that's okay. I'm not perfect. So what do I mean by each object, the amount of each object will be greatly different? Well, think about it. Feathers are less dense. they don't have as many molecules to them or atoms to the same volume. So it will take more volume to make a pound. So you're going to have a great big huge stack of feathers for that part of the joke. Where the bricks are more dense, so it will take less volume to make a pound. So you would end up having a huge old pile of feathers, and then you'll have probably just a part of a brick, probably more like a half a brick. But I couldn't get a half a brick. I didn't have that capability yet. So the less dense, the more volume is needed to get the same amount of weight. More dense, less volume to make your weight. Anyway, so that's it. That's it for today on this PowerPoint. I will have out on Google Classroom an assignment for you to do. So please check your Google Classroom and get your assignments done and make sure you turn them in. Ladies and gentlemen, thank you very much. If this went too fast for you, please check out on Google Classroom for the actual PowerPoint for this, or the Google Slides, and you can go through it at a slower pace as well. And you can watch this as many times as you need to get your notes finished. Thank you, and let's go do our assignments.